My pleasure now to introduce you to Renata Walker, joining our virtual stage today, who is a business-driven product manager within Sama and passionate about the intersection of technology and social impact. As the lead product manager at the company, Renata focuses on creating human-centric products with a data and research-driven approach. So Renata, it's good to have you on our virtual stage. A warm welcome from Berlin. And of course, now I'm handing over to you and the stage is yours. Thank you.
Thank you. Hi, everyone. I'm really excited to be talking to you today about how do we build a robust automotive LiDAR annotation quality rubric. So quickly about me, I've been building products for about 5 years. And previously I was at Coveo building search engines and at Breather. And my expertise is on product and business intelligence to be very strategic, business driven. I manage today Sama's data labeling product, which includes all of our annotation for the 2D, so image, videos, object trackings, and also on 3D, which is what I'm going to be focusing on today, on both 3D vector annotation and also 3D segmentation. Quickly for fun, just for you to get a sense of how I am or who I am from South America, from Los Andes in Chile. And I love playing altiplanic instruments and spend time outdoors, especially in the mountains down here. But I'm actually located in Montreal, and I'm building all the tech, everything in the city of Montreal in Canada. Now, what I'm going to be talking about today is in terms of annotating your 2D and 3Ds type of scene tasks. Why and when do you need a quality rubric? I'm going to talk quickly about what a quality rubric is, how it is important for you to define your system limits when you're creating your quality rubric, defining your quality scoring, what are the common error types that we've seen, and this is the part that we bring our expertise, and thinking about considering trade-offs depending on where you are on your development cycle, and how important it is for you to experiment with your labeling process. And for that, I mean with your internal labelers, with yourself as a labeler, and with your labeling partners. And lastly, I'm going to give you a quick overview of Sama and who we are, and that would be all we're going to be covering today. So let's talk about defining the right quality rubric for your 3D LiDAR annotations. And as I mentioned before, I'm going to be focusing on 3D LiDAR, but this is also applied for also 2D image or video annotations. So make sure to pay attention if you're also working on those type of annotations. And why do you need a quality rubric? Well, let's say I give you all the task of annotating this image, and I'm asking you, what is the direction of travel of these two objects? What would you answer? Do you think it goes up, down, round? This is exactly the reason why a good quality rubric is important, because it means that two people with the same level of information should score the annotation the exact same way. So having a good quality rubric, good and strong annotation instruction will allow you to give your model the information that they need, but properly. So you make sure that all the information is the same and you don't have confusing answers. Now, when do you need a quality rubric? For me, like it's a short answer. It's always. It just means that it would evolve depending on where you are in your development cycle. So if you're starting with your exploratory research, you have to start thinking about it, thinking about your annotation instructions and what are the type of information that you want your model to get back and how important these pieces of information are, the errors, how relevant they will be for your model, so you can make sure that the data that you're annotating is accurate and good. And then as you go advancing on the different phases on the development cycle, this quality rubric will evolve. It will become more robust. It will become more perfect so that anyone can annotate and score the annotation the exact same way. Now, before I even talk about quality scoring and the best practices, we have to think about defining the limits of your systems. So what is your system's expected limits? How accurate is your LiDAR sensor data set? This will really allow you to know what is the actual annotation requirements to boost your model's real benefits. One example well, we have a bunch of considerations to think about when we're talking about system limits. If you think about location accuracy, how accurate is your sensor will give you an information of if you do have a little bit of noise, you might not need perfectly annotated like pixel level or like centimeter level annotation. And that might give you a little bit of a leeway, because the more accurate your annotation is, the more time consuming it is, and with it, it's most likely going to be more expensive. So really think through the different limitations or within your system so you can know what is the actual annotation requirements that you might need. The other will be the camera calibration, how accurate it is, what is your system's performance, the speed in worst case scenarios, the time to crash in worst case scenarios, the HD map accuracy. All of this information will allow you to know what is the type of annotation that you need and what should be your requirements in terms of quality in the annotations per se. Now that we thought about the product, the sensors limitations or your system's limitations, we can start thinking about quality scoring. So what will be a consistent method for scoring your annotation? For each class of annotations, you have to define the core attributes that your model truly requires. Now, the first part of this is having annotation instructions that are good, tight, relevant, and that has visual examples. There's nothing better than a visual examples to convey a message. So the example that I gave you earlier today was of those animals facing we don't know where. Giving those visual examples will help the person that is annotating understand what you really want from your annotation. Then the other thing is think through the error types. It's important for you to know which errors are important and which errors are not that important, because like that, we can understand better what should be the quality penalty that each of these errors should have, and you will be able to flag exactly the problems of your annotations throughout the whole quality assurance process that you might have on your annotation process. So in terms of quality penalty, what is the actual penalty that each error type should have? So sometimes missing objects, well, I'm going to go over the type of errors. Object tracking might not be extremely relevant, or it might be extremely relevant for your product or for your development process or your ML model. So you might want to consider what would be the penalty that you want to give for the different errors that you see. And then the last one will be how will you score your task per frame or per video. When I say per video, I mean per scene. So through all the frames. Sometimes you want to do object tracking. So you want to track a specific car that moves across the scene, and you want to know if that car has been moving properly or not. So in that case, you might want to score the penalties of your task per video instead of per frame. But if you're not really doing object tracking, then it might be much better and easier to do it per frame. Now let's talk about error types. So what are the type of errors you can encounter? At Sama, we've worked with a lot of use cases, with a lot of different type of data, and we've seen a lot of different type of errors that we should definitely be looking into and that you might want to consider when you're building your quality rubric. One of them would be missed objects. So let's say you have a LiDAR with, I don't know, think about 75 meters range, maybe 100 meters range. And throughout the scene, you have a vehicle that just started to show. If you have defined in your instructions that you want that vehicle to be annotated, you might want to be really considerate about that error type because there's like little points, let's say, because it's a longer range, let's say, there might be people that are annotating that might not see these points. So one thing to leverage or to improve the annotation quality will be having proper calibration data and projecting those points to the image. Like that, you can see if there's any objects that are being missed, and you can easily identify this type of errors. But it's important for you to know if you do want to flag this as an error type or not. Another one will be missed points. This will be similar, but like more relevant for 3D segmentation. So you're painting that object, and you might miss a couple of points that should have been part of that object but are not really part of that object, or you might have a cuboid that is not really getting all the points that should be getting from that specific object. So the car is a little bit cut and there's a couple of points that are missing. Another type of error would be inconsistent object tracking. As I mentioned before, sometimes you do want to track the specific car across all of the frames, or you want to track a specific person across all the frames, and you want that object to have one ID. Sometimes some annotators might be annotating them as different objects. So you want to make sure if you do object tracking that you have that error type considered. One example of things that we've seen is that sometimes you do have that car that kind of like moves out from the scene, like the range of view, so you don't see it, and then it comes back. So thinking about that specific edge case, when they come back, do you want those to be the same object or not? And if not, how are you going to be accounting for that type of error so you can make sure that the annotation is properly done as you defined? Another example would be incorrect direction of travel. You might not want to give your model a wrong direction of travel. So if you're going forward and the car is going forward, if there is an annotation error of like it showing backwards, you might not want to give that piece of confusing information if the actual direction of travel of the car is going forwards. Then another one will be incorrect cuboid sizes. If I go back to that example of an object starting to show up in your LiDAR range, you might see it as a blurb of points, and it looks like a sedan, let's say, because it's a small group of points, but it's actually a truck. So you want to give your model the piece of information of that you want. So if you're actually interested in getting the proper cuboid sizes, you can do it by object label. So if that is a truck and you identified that it's a truck by looking in the 2D image, then you should be, or you might want to add that cuboid with the size, minimum size of a truck, and not necessarily the size of a smaller sedan. Another one would be incorrect label. So some annotators might be just tired, or they might not realize and they chose a different label, or they might even confuse a sedan with another type of car. And then these other two error types, they're usually when these are actually like my favorite. One is alignment. So let's think about you have a car that it's moving, you're in a highway, and that car slowly kind of like gets out of the highway. So it's changing the direction of travel toward one side, right? Sometimes annotators, instead of like moving the cuboid like this in all this motion, really representing the motion, they might just do like this and then like that. And that's missing a lot of information for your model. So having an error type or understanding if like the alignment is properly done in the yaw or the pitch or the roll in case you have a car that is kind of like going on the side, but you might want to consider that when you are doing your quality rubric. And then the last one will be jittering. So let's say you're dropping a cuboid and that cuboid is moving through the LiDAR scene, but then the annotation kind of like jumps around. Then in that case, you want to make sure that the movement is in sync with the motion of the object and you're not really having jittering annotations all over the place. Now that we thought about the type of errors, we can think about how we can automate this scoring. So there's two different things in here. One thing that we do have at Sama is that we have auto QA. So we automate some quality scoring. So a lot of those error types, we can actually predict them before the agent or the annotator finished working on that. So you might want to include this type of automatic scoring so you can see beforehand what are the errors that are being made. So direction of travel will be an example of something that you can flag earlier on before it actually goes to your QA process. So you make sure that you have a lot of filters before the annotation actually gets to your model. And the other thing that we do and we love is 3D goal tasks. So goal tasks are pre-scored tasks that new annotations are compared against to determine the score and identify areas of improvements. These are great for training and for making sure that everyone is in the same page in terms of annotations. And for example, if you have a change in instructions, you might want to consider creating some goal tasks just to make sure that all the annotations are aligned and they're consenting in the same type of answers. Some areas that you should consider when you're doing goal tasks, when you're creating them and scoring them, is can you create a perfect task by annotating it manually? If you can't, without those 3D goal tasks, then you might want to go back and rethink about your quality rubric, your error types, and your instructions, so you make sure that you're representing all the missing elements that you were confused about or not sure about when you were annotating. And then the other one will be, does your goal task represent the annotator's performance on real world data? If you give some goal tasks, make sure that you're giving them real, what I called in the wild, reality, so they can include or incorporate all that information when they're working on it. Like that, you will make sure that they're not missing certain knowledge or certain patterns that you might have wanting to see when you're doing quality scoring. Now, after we've gone through all of the different process and things and best practices for you to have the best perfectly annotated task, I'm going to give you a quick tip that you have to think about trade-offs. You have to think about it, time versus quality. So if you're in your early stages of developing your solution, you might want things to be faster, or you want to maybe focus in a more limited use case for testing your solution in closed testing grounds. If you're within that, you might want to just cut off on a couple of quality variables so you can be faster or more agile. Some things that you can cut off or rethink is the ontology size of your annotation, label accuracy. That's a really big one. So if you're actually expecting like a 1 pixel annotation requirement from the beginning without really thinking about your sensor limitations, it might be very hard to achieve the quality requirements that you might need when it's not necessarily that needed for that like phase of your model. If you do lose up a little bit the label accuracy, you're going to get much faster results. You're going to get cheaper annotation as well. And the other element will be thinking about label attributes. Do you really need all that information about that object? Can you cross some information between like one piece of information and others? Or can you just ignore that information in the meantime, and then you can add it when you're a little bit more further on your model development? And one thing that I think it's crucial for you to have a good quality annotation is to experiment with your labeling process. So, well, first you have to match the data size, the data set size with your development phase. So if you're in early exploratory research, just do a smaller batch, as I mentioned before, specific usage or specific like area, and go and experiment iterating on that with your labeling process. If it's yourself, if it's internal labelers, or even if it's external labelers, make sure that you're iterating so you can get all of the knowledge, the edge cases, and the information on that. And focus on returning results as efficient as possible at each stage of the development. If you're really doing a good job at identifying all of this, you will grow your quality rubric to be a robust, comprehensive rubric that will for sure give you the quality that you require for your model. And communicating with your labelers, you being your labeler, it's going to be key for the success of getting the data that you need for your model. Now, who should annotate your data? Your goal is to get the high quality data as fast as possible for your development phase. So agility will be key here. If you're thinking about the exploratory research, internal labeling might be, it's mandatory. You have to be annotating it so you can figure out your edge cases, you can figure out your instructions, what type of errors are the most important for your models, what type of errors might have a little bit more of a wiggle room, and really and know what you need for your model. And then as you move towards more like research testing, you might want to have a larger labeling team because you need more data, right? You need to annotate more data so you can feed that data to your model. But then as you continue on growing, you will need more quality and more data as well. And for you to succeed on both quality and quantity, you need to make sure that you're partnering with someone that knows what they're doing and how labeling should be done. So that's where you're starting to include third-party labeling partners when you're doing simple driving, more complex driving. And then as you grow, you want to make sure that you're partnering with the right labelers so they can adjust, they can give you the quality that you need, and they can go fast in terms of changes on your instructions, because that happens quite often. Now, after I am done talking through all of the tips of how to make sure that you're building a robust quality rubric, let me talk to you a little bit more about what SAMA, like who we are. So we provide quality training data from start to scale. And our mission is to provide accurate data for the world's most ambitious AI teams, harnessing the power of markets for social good. And that's my favorite part. We really thrive by providing quality. I called our annotators to be fighters. Like, they really care about doing the best work that they can do, which makes us being trusted by Fortune 500 because they know that like our quality is the best out there. We have a proven executive team with deep in SaaS and AI knowledge. In that sense, we have internal machine learning teams that are really harnessing the power of ML to improve efficiency without compromising on quality and making sure that the quality standards are always the best. And we're constantly investing in R&D to get the cutting edge products up to the autonomous vehicle industry. Now, the SAMA difference, I think I mentioned this enough on the presentation, is quality. We offer the highest quality SLA, so more than 95%, even on our most complex workflows. And our team really assists on anything from implementing a robust quality rubric to raise edge cases. We really go in depth to understanding what are the nuances of your data set and making sure that everything is properly defined so your model have the right information and not any confusing parameters. Then we are also built to scale. As I mentioned before, we have teams that are building, and we're constantly building on top of our ML assisted annotation that are creating 3 to 4 times efficiency, which allow us to decrease costs and all that while still making sure that our quality is the best. We're also very quickly to adapt to ramp ups. All of our years and years of experience working with different workflows, we have processes in place that allows us to change focus very quickly, really iron on the edge cases, make sure to nudge or like let the customer know whenever something is different, and with changes in frequency up to 2 to 3 times per week per workflow. Now, my favorite part is that we are an ethical AI company. This is the reason why I joined SAMA. We are an ethical AI company that have provided economic opportunities for over 54,000 people from underserved and marginalized communities. And every time that we get new customers, we can get more people out of the marginalized communities to digitalize them and getting them the proper education and insurance and everything that they need to succeed. And lastly, security. We're a tech company and we're obsessed with the security, our tech stack and our physical space. Security and trust are paramount to everything we do. And our delivery sites are ISO certified and employ biometric security. The other thing is our uptime is great, like 99.95 to 99.99 is not something you can see everywhere. Now, to conclude, our key takeaways, reminder that a good quality rubric enables consistency in your labeling. So any 2 people will score the annotation the same way. So your model will not get confusing data. Visual examples are really important to convey the intent of your rubric and your annotation instructions. Think about goal tasks, so pre-score tasks that new annotators are compared against that will aid on setting a standard for high quality annotations. Also match the data set size to your development phase, so you can focus on returning results as efficiently as possible at each stage of your development. And lastly, for complex use cases and later stages of your development, make sure that you find a partner who can help you raise these edge cases, identify these quality rubrics, and deliver labels with uncompromising quality. If you want to learn more, you can visit Tama.com. You can contact sales@Tama.com. You can also go to our virtual booth, or you can even contact me on LinkedIn if you want, on my email, and I will be more than happy to share a little bit more of what we've seen in terms of quality on 3D annotations and 2D annotations as well. Thank you.
All right. Renata, thank you very much for your talk. Pretty impressive what you're doing at Sama, and I guess your work has a lot of impact within the company, and as a team, a huge impact in the AD community as well. So thank you very much for sharing your insights here on our virtual stage. As Renata mentioned, now again, it's time for your questions. So if you have any, you can type them in now in the chat or in the Q&A panel, and I'm happy to read them out loud and that Renata can give a precise answer. And we indeed received one from Kuntal. Is the rubric standardized?
So it will depend. All annotation instructions will be different from depending on your requirements. We do have standardized process to start with, but we are always adapting to what the customer really needs. So it's not a standard process. We are adaptive and customized to the specific customers. But it starts from the base of everything that you need to consider when you're doing annotations.
All right, thank you for the answer. Any more questions from the attendees? So might we give them a second to type in another question? Also, maybe Renata, for you in the meantime, do you would like to sum up your talk with a concluding remark?
Yeah, sure. So as I mentioned before, I truly believe that the level of requirements that you define for your models are going to be key on the success of your model's performance. It will depend on where you are in the development cycle. At the beginning, you might want to do only vector annotation with a high, let's say not that perfectly accurate annotations, so you can decrease the cost and be faster and you can get things moving faster. But then as you move towards further down the line in your development, when you're thinking about more complex cases, you might need higher quality annotation, and you might even think about changing from vector annotation to segmentation and do instance level segmenting and painting all the different points of your annotation. So it all will change the amount of time that is going to take you to get the annotations, and it can be fast if you do have the budget to get all of the annotations ready. If you want to start with 3D segmentation from the beginning, you might have too much of a quality of too much information for the beginnings of it. So try to make sure that you're agile when you're doing your labeling process, and make sure that you're including all the quality requirements that you need at the right stage of your ML development.
All right. Quite a detailed summary, but fantastic delivered. So Renata, it was a pleasure to have you on our virtual stage here. Really fantastic talk, and really much looking forward to hopefully meet you and the Sama team next year at one of our live stages, hopefully. So till then, I wish you all the best, great hikes, and thank you very much for being one of our speakers today.
No, thank you for the invitation. Very happy to be sharing. Have a good day. Bye.
Thank you.